Check the clock on your wall right now. It's ticking once per second, steady. But that's a lie. Your clock is lying to you, and so is every clock you've ever owned. Time does not move at one speed. It bends, it stretches, it runs slower for some people and faster for others. And this isn't science fiction or a movie plot. It's a measured, proven fact of the universe we live in. Time travel into the future is real, and humans have already done it. But there's a catch, and it's a brutal one. You can only go one direction. To understand why, we have to start with a man and a strange idea in 1905. His name was Albert Einstein, a 26-year-old clerk working in a patent office. He wasn't even a professor yet, and he asked a question so simple it sounds childish. What would you see if you chased a beam of light? Everyone assumed the answer was obvious. If you run fast enough, the light slows down next to you. Just like a car beside you on the highway seems to sit still. But Einstein realized something terrifying. Light refuses to slow down. No matter how fast you chase it, light always flees from you at the exact same speed. 300,000 kilometers per second, every single time. You can run at almost the speed of light, and the beam still races away at full speed. That should be impossible. So Einstein followed the logic to its breaking point. If light's speed never changes, then something else has to give. And the thing that gives is time itself. Here is the rule that broke physics forever. The faster you move through space, the slower you move through time. We call this time dilation. Picture two twins, both exactly the same age. One stays home on Earth, the other climbs into a spaceship. That ship accelerates to near the speed of light and flies off into the dark. For the traveling twin, everything feels completely normal. Her heart beats once per second. Her clock ticks once per second. She feels nothing strange at all. But back on Earth, time is racing ahead. While 1 year passes inside her ship, 100 years pass on Earth. 1 year for her, 100 years for everyone she left behind. She returns home barely older, expecting to see her family. But her twin is gone. Her parents are gone. Everyone she ever knew is dust in the ground. She has traveled 100 years into the future, in a single year of her own life. And here's the part that makes people stop breathing. This is not a thought experiment. This actually happens, and we have proof. In 1971, scientists took 4 atomic clocks and put them on airplanes. They flew those clocks around the entire world and then compared them to clocks left on the ground. The flying clocks came back behind. They had ticked slightly slower, by billionths of a second, exactly as Einstein predicted. The faster clocks had literally traveled a tiny bit into the future. But planes are slow compared to light. So who holds the real record? Astronaut Sergei Krikalev spent 803 days orbiting Earth at 17,000 miles per hour. Because of his speed, he aged just slightly slower than the rest of us. When he came back, he had traveled 0.02 seconds into the future. That makes him the greatest time traveler in human history. A real person who is now permanently a fraction of a second younger than he should be. But speed is only half the story. Because there's a second way to bend time, and it's even stranger: gravity. Einstein discovered that heavy objects don't just pull on you, they actually slow down time around them. The stronger the gravity, the slower time crawls. Your head, right now, is aging slightly faster than your feet. Because your feet are a little closer to Earth's gravity, time is running slower down there. It's a tiny difference, but it is real and measurable. Now push that idea to its limit. Imagine the most extreme gravity in the universe. A black hole. Near a black hole, gravity is so violent that time nearly stops. There's a movie that got this exactly right. A team lands on a planet orbiting a giant black hole. They spend what feels like a few hours on the surface. But that planet's gravity warped time so severely that for every 1 hour there, 7 years passed back home. The crew member who stayed behind aged 23 years while they were gone. That scene was built with real physics, checked by a real physicist. This is the universe we actually live in. So future time travel is settled. Go fast or sit near crushing gravity, and you will arrive in the future younger than everyone else. Which leads to the question everyone is really asking. What about going back? Can we travel into the past? And here is where the universe slams the door. Going forward is easy because you're just slowing your own clock down. But going backward means making time run in reverse. And reverse time breaks reality itself. Picture the grandfather paradox. You travel to the past and stop your own grandparents from ever meeting. Then your parents are never born, which means you are never born, which means you never traveled back to stop them. You both exist and don't exist at the same time. The universe cannot hold two opposite truths at once. Physicists have searched for loopholes for a century. Wormholes, cosmic strings, spinning universes. Every single solution requires something we've never found. Exotic matter with negative energy that may not even exist. Stephen Hawking had his own playful test for this. He once threw a party for time travelers, but he only sent out the invitations after the party was over. If backward time travel were possible, future guests would have read it and shown up. Nobody came. The empty room was his answer. The future is open to us. The past is sealed shut. So think back to that clock on your wall. It's still ticking once per second, or so it seems, but now you know the truth hiding inside it. Every step you take, every time you stand up, every time you move, you are nudging your own clock out of sync with the world. You are time traveling right now by impossibly small amounts, whether you feel it or not. We are all drifting forward through time together. Some of us just a heartbeat ahead of the rest, and not one of us will ever go back.